When you complete calculations involving surds, you often need to simplify them so that they are easier to work with. But how do we simplify surds? In this video, I'm going to show you an easy way to do just that. First, I'll explain briefly how to simplify surds, before quickly moving on to a couple of simple rules and walking you through some example questions. In this video, I'll cover the first 3 examples, and I'll cover the other 3 in the next video. Finally, I'll give you a summary of key points to remember. Simplifying surds involves making the number under the square root as small as possible. We can do this by finding square numbers which are factors of that number. For example, we can simplify the square root of 50. First, we can list all of the factors of 50. 1 and 50, 2 and 25, and 5 and 10. Now we need to look for the pair which has a square number. In this case, it's 2 and 25. Once we've found this pair, we can rewrite the original surd as the product of these factors. For example, root 50 can be rewritten as root 25 times root 2. We can simplify this further to 5 root 2. Before we dive into any of the examples, there are 2 simple rules to remember, one of which we've already seen. Given any 2 numbers, a and b, the square root of a multiplied by the square root of b is the same as the square root of a times b. This is the rule that we'll use in this video. In the next video, we'll look at the second rule. The square root of a divided by the square root of b is the same as the square root of a over b. Now that we've covered the rules, we can work through some examples. In this first example, we need to simplify the square root of 12. First, we're going to write out the factors of 12 and then find the factors which are square numbers. The factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Now, looking at our list of factors in perfect square numbers, we can see that 4 is a square number. Therefore, we're going to take the pair 3 and 4 and rewrite root 12 as root 4 times root 3. We can simplify this expression further to get 2 times root 3, which gives us 2 root 3 as a final answer. Moving on to the next example, we need to simplify the square root of 192. Now, we could try to list all of the factors of 192, like we did before. However, this might take quite a while for large numbers. Instead, I'm going to show you a faster method which involves using times tables. Working down the list of perfect square numbers, we're going to work out if they are factors of 192 by using division. Since we know that 1 is always going to be a factor, we'll start with 4. For each square number, we're going to ask, does 192 divide by this number? In the case of 4, the answer is no. So we'll try 9. Again, 9 isn't a factor of 192, so we'll move on to 16. 192 divided by 16 is 12, so 16 is a factor of 192. Thus, we can rewrite the square root of 192 as root 16 times root 12. We can simplify this expression further. Root 16 simplifies to 4, and root 12 simplifies to root 4 times root 3. We can keep simplifying to get 4 times 2 times root 3, which gives us 8 root 3 as a final answer. Now, looking at our third example, we need to simplify 5 root 98. This time we're going to go through the same process as before, finding the factors of 98 which are also perfect square numbers. In this case, 49 is a factor of 98 and a square number, so we can rewrite 5 root 98 as 5 times root 49 times root 2. We can simplify this to get 5 times 7 times root 2, and once more to get the final answer of 35 root 2. Looking at the examples, we can summarise a few key points. The aim of simplifying surds is to make the number under the square root as simple as possible, and we do this by finding factors which are perfect squares. To start with, I'd recommend writing out the list of perfect squares, and if you're struggling to determine which square numbers are factors, you can always write out the factors of the initial number. In this video, I've shown you how to simplify surds using multiplication, and in the next video, I'll show you how to simplify surds using division.